In 1956, Swedish engineer Sven Berge presented a turretless tank project to the military leadership. Everyone thought he had lost his mind. Generals laughed, experts shook their heads. Foreign specialists called it a technical absurdity. A tank without a turret was considered self-propelled artillery, not a real combat tank. But 10 years later, this crazy machine was in service with the Swedish Army, and 20 years later, British and American tankers tested it and recognized it as revolutionary. How did one man manage to convince an entire country to build a tank that defied all the rules of tank construction? And why did this strange machine serve for 30 years, even though everyone predicted its failure? The Cold War was gaining momentum, and small, neutral Sweden found itself in an extremely unpleasant situation. The threat of the Soviet Union with its thousands of tanks loomed from the east, while the Swedes' own tank fleet looked depressing. They were armed with British Centurions, huge 3-meter giants that weighed 50 tons and could barely accelerate to 35 kilometers per hour. These clumsy monsters were poorly suited for defending Swedish forests and lakes. A native tank was needed, adapted specifically for Swedish territory. In the early 50s of the 20th century, the Ministry of Defense launched a development program for a new heavy tank, codenamed KRV. The requirement sounded ambitious: a weight of about 30 tons with powerful armament, good protection, and high mobility. A consortium of Landsverk, Volvo, and Bofors proposed a project with a huge 155mm gun in an oscillating turret. The project looked impressive on paper, but it had one problem: cost. The KRV program required colossal investments that small Sweden simply could not afford. In 1953, when the British unexpectedly agreed to sell Centurions directly, work on the KRV was formally frozen, but informally, discussions continued. The military understood that the Centurion was a temporary solution, not an answer to the long-term problems of Swedish defense. It was at this moment that Sven Erik Berge entered the scene. This 40-year-old engineer worked at the Royal Army Ordnance Administration, where he inspected tank production. But Berge was not just an official, he was a tank troops reserve officer. He drove tanks himself and understood their problems from the inside. Most importantly, Berge was fluent not only in Swedish and English, but also in French, German, and Russian. This allowed him to study specialized literature on armored vehicles from all over the world, reading the original technical reports and military studies. In the summer of 1956, Berge finished analyzing reports on tank losses in World War II and the Korean War. The statistics were shocking. The risk of being hit in battle depended directly on the height of the vehicle, with more than half of all tank losses occurring due to turret penetration. Berge came to a radical conclusion. Any new tank had to be as low as possible, and the easiest way to make a tank low was to remove the turret entirely. On October 22, 1956, Berge filed a patent application titled Notification of a Swedish Invention. The document described a technical solution for aiming the gun using the tracks of the tank itself. The idea looked crazy. Instead of a rotating turret, the entire tank had to turn in place for horizontal aiming, and a special suspension would be used for vertical aiming, which could raise and lower the entire hull. When Berge presented the basic concept to his department head Höglund and the head of the Vehicle Bureau Eric Gillner in August 1956, the reaction was reservedly cold. A tank without a turret sounded like a step back to the 1930s, to assault guns and anti-tank self-propelled guns. But Berge was incredibly convincing in his presentation. He was not just proposing to remove the turret, he was offering a whole philosophy of tank construction based on the analysis of real combat losses. Berge studied the successes of World War II tank destroyers. The Sturmgeschütz and Jagdpanzer models showed exceptional effectiveness in defense due to their low silhouette and excellent maneuverability on short tracks. He also analyzed the French Char B-1 with its precise transmission that allowed aiming the hull howitzer. Berg wanted to combine these advantages, low profile, excellent handling, and precise aiming, into a single vehicle. But this required a fully automated transmission and a revolutionary suspension system. Despite the skepticism, Berg received permission to continue development. The military leadership understood that if the concept worked, Sweden would get a tank that would cost much less than traditional vehicles, while offering comparable combat effectiveness. In conditions of a limited budget, this sounded tempting. By 1957, the situation had changed. The KRV program finally failed due to armament problems, and the military began looking for alternatives. In the spring of that year, work started in 3 directions simultaneously. The first direction, named Stridsvagnen A, followed the British-American School of Tank Construction, a vehicle weighing 42.5 tons with a decent silhouette and a power-to-weight ratio of 20 horsepower per ton. The second direction, Stridsvagn T, represented the Franco-German school, a light 32-ton tank with thin armor but high mobility, from 30 to 35 horsepower per ton. And the third direction was Berge's concept, which received the name Stridsvagn S, where S stood for Sverige, meaning Sweden. All 3 variants were to be armed with a 105mm gun, but only variant S involved abandoning the turret. For the military, it was a crazy experiment. For Berge, it was a chance to prove he was right. To test the feasibility of the concept, Berge ordered Bofors to create a prototype of the suspension and transmission system. Engineers took decommissioned American Sherman tanks and Swedish IKV-103 assault guns and installed an experimental hydro-pneumatic suspension on them. The results exceeded expectations. The system worked. The suspension could precisely raise and lower the hull, providing vertical gun aiming. For further testing, the system was installed on a chassis from the uncompleted Kranvägen project, removing 2 road wheels to bring the configuration closer to the future tank. In 1958, the Swedish parliament held a debate on which of the 3 alternatives to choose. The discussion was hot. Supporters of Variant A pointed to the proven design and reliability. Defenders of Variant T spoke of superior mobility. And Berge argued that only his turretless tank could combine low-cost, excellent protection, and sufficient firepower for Swedish conditions. The decision was unexpected. Parliament chose Alternative S, despite the fact that it was the most expensive of the 3 options. Why? Because this tank had symbolic meaning. Sweden, a neutral country, wanted to show the whole world its industrial competence. Creating a fundamentally new type of tank that no one else had was a matter of national prestige. Bofors received a contract to build 2 prototypes, which were named S1 and S2. Landsverk built the transmissions, and Volvo assembled the engines. The S1 prototype received an electric motor as a power plant for suspension testing, while the S2 prototype was equipped with a unique hybrid power plant from Volvo, combining a diesel engine and a gas turbine. This was an absolutely pioneering solution. No one had ever put a turbine on a production tank before. In the fall of 1958, Bofors presented the first conceptual drawings of the future tank. The machine looked like a low wedge, almost flat in front. The hull length was nearly the same as the Emil project, but the similarity ended there. Stridsvagn S turned out to be 70 centimeters wider and 40 centimeters higher. The estimated mass was 31 tons. The engine and transmission compartment were placed in the front, which was another non-standard solution. The power plant was to be combined. A 300 horsepower diesel for normal movement, and a 200 to 300 horsepower gas turbine for high speeds and difficult terrain. The armament also turned out to be unusual. The gun, rigidly fixed in the hull, was equipped with an autoloader that fed from an ammunition bustle in the rear of the vehicle. This meant that the crew could be reduced to 2 or even 1 person. No loader was required. On January 3, 1961, Berger received American patent number 2,968,828 for his active suspension. By this time, the military finally approved Stridsvagn S as the main direction of Swedish tank construction. However, Variant A was not completely rejected. Bofors continued to work on both projects in parallel for some time. The first prototype, S1, turned out to be a suspension demonstration rig. Instead of the standard engine, an electric motor was installed, and a British 105mm L7 gun was used as armament. The most interesting part is that this was the only tank from the Stridsvagn S family that received a turret. Yes, a small turret with a 20mm automatic cannon was temporarily installed on the turretless tank. However, to maintain secrecy, the hull was covered with sheet metal so that no one could see the real design. Work was in full swing. The Swedes were developing the armament and power plant in parallel with the tank itself. The experimental vehicles were supposed to receive a 6.34-liter Rolls-Royce B81 diesel engine with a capacity of 230 horsepower. However, in mid-January 1961, a decision was made that the Zero Series tanks, starting from the third vehicle, would receive different engines. The Swedes already knew back then that the Boeing turbine would be a bit weak, but the military would only find out about this after the start of serial production. In 1960, the Army ordered 10 pre-production vehicles. These tanks arrived for testing in 1963. Military tankers began testing the unprecedented design and immediately ran into a problem. 2 crew members could operate the tank and fire, but technical maintenance, guard duty, and ammunition replenishment required more people. The solution turned out to be unusual. They added a 3rd crew member and seated him facing backward. This driver radio operator was located in the rear of the tank with his back to the direction of travel, equipped with a full set of controls. Why? So that the tank could retreat at maximum speed in reverse, always keeping its frontal armor toward the enemy. The rear driver simply took over control, and moving backward became moving forward for him. In the spring of 1963, the tank was shown to the public for the first time, causing a worldwide sensation. Even United States President John F. Kennedy expressed interest in the design. Secretary of Defense Robert McNamara wrote a memo noting the advantages of the Swedish tank over the American M60 in its low silhouette, lower weight, and amphibious capability. The Americans were forced to admit that small, neutral Sweden had created something revolutionary. For armament, they chose the British 105mm Royal Ordnance L7 gun. The gun ran through the entire tank, and the casings were automatically ejected through the rear. The autoloader worked at an incredible speed, 3 seconds between shots. This meant 15 shots per minute, surpassing most tanks with manual loading. The autoloader was fed from 2 magazines, one for 25 armor-piercing shells, the other for 20 high-explosive shells. In 1971, the armor was tested by firing solutions. Armor-piercing shells with a speed of 1,308 meters per second had only a 50% chance of penetrating the sloped armor, while the thickness of the frontal plate was only 40 millimeters. The secret lay in the angle of inclination, 78 degrees from the vertical. The effective thickness increased significantly. The tank received the designation Stridsvagn 103. Its height was only 2 meters 14 centimeters, compared to 3 meters for the Swedish Centurions. The suspension allowed lowering the hull by another 13 centimeters. Behind the crest of a hill, the tank practically disappeared from sight. A bulldozer blade was located under the nose for rapid entrenching. The most radical feature was the power plant. 2 different engines worked together. A Rolls-Royce K60 diesel engine with a capacity of 240 horsepower for normal movement, and a Boeing 502 gas turbine with a capacity of 300 horsepower for high speeds. Stridsvagn 103 became the world's first production tank with a gas turbine engine. The Soviet T-80 and the American Abrams would appear only many years later. The tank became fully amphibious in 25 minutes by deploying a folding screen. The tracks propelled the vehicle through the water at a speed of 6.5 kilometers per hour. In the fall of 1964, the Army ordered 70 production vehicles. The first Stridsvagnen 103A tanks entered service in 1967. And here it turned out that the 300-horsepower Boeing turbine was hopelessly weak. The specific power was only 14.3 horsepower per ton instead of the planned 18. In 1970, production began on the B version, with a Caterpillar turbine producing 490 horsepower. The total power reached 730 horsepower. All previous tanks were modernized to this standard. By the end of 1971, 290 tanks had been built. And now, for the most interesting part, how the crews reacted to this strange machine. In 1967, Norway compared the Stridsvagn 103 with the German Leopard 1. With the hatches closed, the Swedish tank detected more targets and fired faster. In 1968, the British Tank School in Bovington tested the vehicle for 6 months and admitted that the turretless concept had significant advantages. The British, creators of legendary tanks, praised the radically new design. In 1973, the British Army of the Rhine conducted maneuvers with the Stridsvagn 103. Technical readiness never dropped below 90%. The final report stated, "It was not possible to prove any disadvantage in the inability to fire on the move." In 1975, the Americans tested the tank at Fort Knox. The Stridsvagn 103 fired more accurately than the American M60, though slower by only half a second. Critics argued that the tank was only good for defense, but Swedish doctrine was aggressive. Brigades with the Stridsvagn 103 were called assault brigades. Their task was to counterattack against landings. The low profile was for crew protection during an offensive, not for passive defense. All 3 crew members could drive and shoot. Even after losing 2 people, the tank remained combat capable, which was a unique feature. By the 1970s, the Stridsvagn 103 had proven its worth. In the 1980s, modernization to version C began, introducing a new Detroit diesel, a laser rangefinder, and an improved fire control system. But what happened next to this strange tank, and why was it eventually abandoned? The Stridsvagn 103 had another secret feature that the world only learned about in 1992. A special bar armor, a metal grid at a distance from the main hull, was mounted on the front of the tank. This protection was kept in the strictest secrecy and was planned to be installed only in the event of a real war. Why such secrecy? The grid was intended for the premature detonation of shaped charge shells and anti-tank missiles. When a munition with a shaped charge warhead hit the grid, it either exploded ahead of time, at a distance from the real armor, or the fuse was damaged and the shell did not detonate at all. Tests showed high effectiveness against anti-tank missiles and recoilless guns of the 1970s. The cumulative jet, having traveled a meter or a meter and a half through the air after a premature explosion, lost a significant part of its penetrating power, and if the fuse was damaged, the shell simply failed to work. Additional protection was provided by fuel canisters placed along the sides, starting with version C. They served simultaneously as additional tanks and as anti-cumulative shields. The Swedes thought out the protection to the smallest detail. By the 1980s, a problem arose. Soviet tanks received new ammunition. 125mm sub-caliber shells from the T-72 tank penetrated the frontal armor of the Stridsvagn 103 right through from the front part to the engine compartment. The Swedes understood this perfectly. In 1980, the Army demanded to decommission all tanks and replace them with the new Stridsvagn 2000. But in 1982, the military budget was cut, and instead of new tanks, ordered the modernization of the old ones. Development began on version D, the most ambitious modernization. They planned to install a new gas turbine, a weapons of mass destruction protection system, thermal imagers for the gunner and commander, an improved ballistic computer, a gun reference system, improved suspension damping, additional frontal armor, and even an independent stabilizer for the commander's machine gun. One prototype of the Stridsvagn 103D was built, but things went no further because at the end of the 1980s, the unexpected happened. The Cold War ended. The Soviet Union dissolved, and the threat of invasion disappeared. Military budgets were sharply reduced. The Stridsvagn 2000 program was canceled. The Swedes needed new tanks, but developing their own became economically unfeasible. In 1991, they decided to purchase foreign vehicles. A tender was announced in which 3 tanks participated: the American M1A2 Abrams, the upgraded German Leopard 2, and the French prototype Leclerc. The tests ended with the victory of the Leopard 2. The American Abrams took second place, and the Leclerc was eliminated partly because it was still in the development stage. In 1994, Sweden leased 160 outdated Leopard 2A4 tanks from Germany under the designation Stridsvagn 121, while waiting for the delivery of the new Leopard 2A5 models, which would become the Stridsvagn 122. But before decommissioning the old Stridsvagn 103, the military decided to conduct one final experiment. In the late 1990s, military exercises were organized at the training ground in Kvarn. 7 Stridsvagn 103 tanks took up defensive positions against 7 brand-new Stridsvagn 121 German Leopard 2A4 tanks. The result was astounding. The 30-year-old turretless tanks, which everyone considered obsolete, destroyed all 7 modern Leopards, losing only one vehicle. The low silhouette, the high rate of fire of the autoloader, and the ability to quickly occupy and leave firing positions in reverse all gave the old design a decisive advantage in a defensive battle. The tank without a turret, which had been laughed at 40 years prior, defeated the best main battle tank in Europe at that time. But this was the swan song of the Stridsvagn 103. 1997 was the last year for this tank. It was decommissioned not because it fought poorly. It never participated in real combat operations. The reason was more mundane. Modern tanks possessed thermal imagers, computerized fire control systems, and the ability to fire accurately on the move. The Stridsvagn 103, with its 105mm gun and analog instruments, was simply morally obsolete. 30 years of service is an excellent result for any tank, and for such an unusual design, it is a real achievement. The story of the Stridsvagn 103 is unique. Engineer Sven Berge proposed a crazy idea, a tank without a turret, and managed to convince an entire country to build 290 of these machines. Everyone predicted failure, but the tank turned out to be so successful that it served for 3 decades and defeated its successor in the final duel. So what was the secret? Why did this strange machine turn out to be viable, even though no one else in the world dared to repeat the Swedish experiment? The answer lies in the specifics of Swedish defense. Sweden was not going to fight in the deserts of the Middle East or on the plains of Central Europe. The Swedish theater of military operations consists of forests, hills, and lakes. Here, the capacity to fire at maximum speed while pursuing an enemy is not what matters. Instead, it is the ability to quickly occupy a favorable position, deliver a precise strike, and retreat. For such conditions, a low silhouette, a high rate of fire, and the possibility of a quick retreat in reverse turned out to be more important than a rotating turret. The Stridsvagn 103 became the first production tank with a gas turbine engine, opening the way for the Soviet T-80 and the American Abrams. Its hydro-pneumatic suspension for aiming the gun inspired the creators of other vehicles. The concept of an autoloader and a reduced crew also received further development. The tank, which everyone considered a dead end of evolution, actually anticipated many technological solutions of the future. Today, several Stridsvagnen 103 tanks are kept in the Swedish tank museum Arsenalen, all in working condition. Among them is the only prototype of version D, a testament to what the modernization could have been if the Cold War had not ended. These machines remind us of a time when a small, neutral country challenged all the canons of tank construction and won. Sven Berge proved that sometimes the craziest ideas turn out to be the most resilient.